This lesson is on solving systems of linear inequalities by Dr. Archie Earl. These are the steps involved in solving systems of linear inequalities. Step number 1, graph the inequalities in the same XY plane. Step number 2, shade the region that they have in common. Here's an example. Find the solution set for 10x minus 2y is greater than negative 8 and 4x plus 3y is less than or equal to 12. The first equation we've already graphed. This was the first equation. This is the first equation. 10x minus 2y is greater than negative 8. So we solved it for y, and then we got the corresponding equation. We solved it for y, we got the corresponding equation, we graphed the corresponding equation, and then since we had less than, we made it dashed, and since we had less than, we shaded below. So we've done the first equation in the system. So we have to do the second equation, and we have to put the second equation on that same graph. So I'm going to graph the second equation on the same graph, and then my final graph will be the intersection of those two graphs. So the second equation in the system is 4x plus 3y is less than or equal to 12. So the first thing we have to do is solve that for y. So I've done that here. I hope that you can see this clearly. The first equation, the equation is 4x plus 3y is less than or equal to 12. To solve that for y, I subtract 4x from both sides. And when I do that, I get 3y is less than or equal to negative 4x plus 12. Next, I have to divide both sides by 3. So I have 3y divided by 3 is less than or equal to, and I'm dividing both sides by a positive number, so I don't have to reverse my inequality sign. I start out with less than or equal to, and I end up with less than or equal to because I did not divide both sides by a negative. So I'm dividing both sides by 3. And when I do that, I get y is less than or equal to negative 4/3 x plus 4. And now I have to find 2 points and draw my line. So I chose to use 0 and 3 for my x. So I substituted those into the equation and I solved for y. And I have here in my table, when I substituted 0 into the equation, I got 4 for y. When I substituted 3 into the equation, I got 0 for y. So those are my 2 points that I need to graph in that same rectangular coordinate system with the other equation. So I'm going to do that now. Okay, 0, 0, 4. I don't go any right or left. I just go up 1, 2, 3, 4. So that's the same as the point I already have there. And then I go 3 to the right. I have 3, 0. That means I go 3 to the right and just stay there because y is 0. So I go Start at the origin, go 3 to the right, 1, 2, 3, and I just stay there. So that's my point there. And then I draw my line through my 2 points. If you have graph paper, I would suggest using graph paper to do your graphs. So now I ended up with less than or equal to in this case. So that means my line will be solid because I ended up with or equal to on there. That means that y can be equal to the line. And I have less than, so I'm going to shade below. If you have less than or equal to or less than, that means that you shade below the line. So I'm going to shade below this line. And the solution is the place where the 2 graphs intersect. So to see clearly where the 2 graphs intersect, I'm not going to make my shading vertical like I did in the first case. Instead of making my shading vertical, I'm going to make my shading horizontal so that I can actually see where the 2 graphs intersect, you see. But since I have less than or equal to, that means I shade below this line. But I'm not going to shade it this way. I'm going to make it across like this so that I can easily see where the 2 graphs intersect. The intersection is the answer, you see. So that's what I would have there. And of course, you can extend this over because the line extends indefinitely in that direction. So you can extend this over here, and you can see where the 2 graphs intersect. You see where you see the rectangles. That's where the 2 graphs intersect. So you only have that for your final solution. You only have the intersection for the final solution. So I can bring this a little closer to the camera so that you can see here exactly what we have. We have like little rectangles, and that's where the graphs intersect. So you erase all except that region. So this region over here would be erased. This region would be erased. You see, that's not where they intersect. The solution is where the graphs intersect. So I don't have any little rectangles over here, so I can erase that. You can erase all parts where you don't have the rectangles, because those parts do not represent intersections. If you have 3 inequalities, you use basically the same procedure. Where you have the final graph, it will be where you have the most intersections. You see, that will be the final graph. So the final graph is just this area in here. That's where they intersect. Now sometimes when we do problems later, we'll be just talking about the first quadrant. But for now, you get the entire intersection of the 2 graphs for solving systems. So that would be the solution to that system. For homework, you want to do page 401, number 1. Nope, that's not right. That was previously. All right, for this assignment, for solving systems, you want to do this homework assignment on page 401, number 23 and number 31. You have 2 systems, and you want to solve those systems as I've shown you here. You have to graph the inequalities in the same XY plane, and then you have to get the intersection and shade the intersection. The assignment here also indicates that if your professor has given you a different assignment, then you want to do that assignment. If you're just looking at this video for self-enrichment, then you can get any algebra textbook and look at some of the exercises in there and do some of those exercises to practice. That's it for today. Thank you. Bye now.